Okay, so here we go. We are going to actually work backwards today. So if you are feeling a little bit iffy about graphing, today will definitely be helpful because we're going to work backwards. I'm going to give you a graph and you are going to write the equation. Okay, so help me out. When I give you an equation, what information do we need from the equation to actually graph sine or cosine? Okay, we need the amplitude, and we find the amplitude by taking the absolute value of A. Okay. What else do we pick out? Oh, and what's the next thing we usually look for? Okay, how do we calculate the period? Two pi divided by B. Okay, and then the last thing we look for is what, Kristen? Okay, and what is the starting point? D. You know what number to look for, right? Okay. So what we're going to do today is we are going to be given a graph, and I'm even going to give it to you in a frame. And from the graph in the frame, we need to identify, hey, what's the amplitude? So we can figure out the A for our equation. What's the period? Well, the period equals 2 pi over B. We need to solve for B. Okay. Where's the starting point of the frame? Okay, well, that's the same as C over B comma D. So we can solve for C and D. Okay. So by the end of these problems, you are either going to write y equals a cosine of bx minus c plus d, or you're going to write y equals a sine of bx minus c plus d. So we'll have to pay attention to also, is it a sine or cosine graph, and is it reflected? Okay. But once we identify basically those 5 things, sine or cosine, A, B, C, D, then we can write our equation. Okay. Good news, you have a worksheet for tonight's homework. I thought you'd be a little bit more excited about that. Okay. Okay, I'm excited. I don't know why worksheets are more exciting than book work, but over my 14 years of teaching, that is what I've learned as a teacher. Worksheets are more exciting. Okay. Okay. So here we go. I need you to draw this in your notes. If you don't have it drawn, you're going to have no idea what happened. So I'm going to give you some time to draw this in your notes, labeling those numbers, and then we'll talk through how to complete the problem. Nate, is this a sine or a cosine graph? It's a cosine graph. So we know we have y equals a cosine of bx minus c plus d. That's the equation that we need to write, and we need to identify a, b, c, and d. Okay. So this is what I'm going to do, and you don't have to do what I do, but I am going to draw a frame. Okay. That way I can see the height and the length of my one period a little bit easier. Okay. So if we look at this graph and we look for the amplitude, okay, the total height of this frame you would consider to be what? The total height of the frame. This has a height of 4, okay? So our amplitude is going to be 2, okay? Now, would you say that this is a normal cosine or a reflected cosine? Normal. So A is going to equal just a normal 2. Okay. Well, now let's find the length, the horizontal length of this frame. Okay. Well, our frame begins at x equals 0 and it ends at 2 pi over 3. So this frame has a length of 2 pi over 3. Our period is 2 pi over 3. Now we know that we calculate the period by taking 2 pi divided by b. So 2 pi divided by b equals 2 pi over 3. What does that mean b equals? Tough work right there, right? Okay. If we didn't have such a nice proportion set up, you could cross multiply to solve for b. But this one was pretty obvious that b was going to be 3. Okay. Now remember, and this is something that we talked about Tuesday when I was here. Our starting point is for our frame, not the equation. So our starting point is right here where the frame begins. And what is our starting point? 0, 0, which means C and D are both 0. So our equation is going to be y equals a positive 2 cosine of 3x. Right? Minus 0 and plus 0, but it's not necessary. Okay. So this is what I am looking for right here. And okay? Yeah. Okay. Good. I want you to go ahead and draw this one for me. So the longest part of notes is just drawing these graphs in so you can look back and understand what's going on. So I need you to draw it in. At least have the -2 and the +6, and at least have the 2 all the way to the x-axis. beautiful frame, but it's a frame. All right. Okay. What kind of graph are we working with? Jonathan, what kind of graph do we have? Sine or cosine? We have a sine graph. All right. So we know that we are going to be filling out y equals a sine of bx minus c plus d. Okay. All right. So let's talk about our amplitude. Okay. Now this frame, we've shifted up a little bit. So I want you to think about the total height from -2 to 6. How great of a distance is that? 8. So our amplitude is 4. Okay. Now, is this a normal sine graph or a reflected sine graph? It's reflected. So our A is actually -4 because we have an upside down sine graph. Okay, this one's nice again because our frame begins at x equals 0 and our frame stretches all the way to x is 2. So this frame has a horizontal distance of 2, which means the period of this graph is 2. And our period is calculated by 2 pi divided by b. Okay, now some of you can look at that proportion and solve it, no problem. Some of us really like to do all the steps. So when we are solving for b, we need to cross multiply, and then we can divide by 2. You okay? Okay. All right, last we're going to talk about our starting point. It looks like our frame begins right here at 0, 2. Okay. Well, what does that mean? Well, if the x coordinate of our starting point is 0, then we don't have a c value. Okay. And then we are shifted up 2, so that's going to affect d. So we have y equals -4 sine of pi x, and then outside the parentheses we'll have +2 for that vertical shift. If your graph does not have a horizontal shift, this process isn't too intimidating. Okay, the vertical shift's always easy to pick out. The a value is always going to be fairly simple to pick out. Sometimes calculating b takes a couple steps, but it's not a big mess. Okay. Now, once we put in that horizontal shift, solving for b and solving for c is a little bit more involved. Okay. So let's go ahead and draw this graph in our notes. You don't know about Kool-Aid? Okay, so Kool-Aid was invented in Casey Chris. Okay, and so much like we have Kool-Aid, they have Kool-Aid. Okay. Now you don't have to draw the frame. I just find sometimes it's helpful. Okay. When we look at this graph, do we have a sine or cosine curve? Okay, so A cosine of bx minus c plus d. Okay. Let's first identify our amplitude. Okay. Our amplitude, well, it looks like our frame stretches from -2 to +2. So we have a vertical height of a total of 4. So our amplitude is going to be 2. Now, is this a normal cosine or a reflective cosine? Okay. Notice how it starts out at the bottom and looks like a hill. So we have a reflected cosine, which means this is going to be a -2. Okay, now we got to figure out the length of our frame horizontally. Okay, if I begin, okay, let's think of a ruler. What's the distance from 3 inches to 6 inches? Grayson, how'd you get that? Okay, so if we're measuring a distance, we can take where we stop and subtract where we start. So if I want the period of this graph, then we need to take where we stop, pi over 2, and subtract where we begin, pi over 6. And that'll give us the total distance. Okay, so this is end minus begin. So pi over 2 plus pi over 6 is what we're dealing with. Okay. Well, pi over 2 is the same thing as 3 pi over 6. Do you agree? So we have 3 pi over 6 plus 1 pi over 6, which is 4 pi over 6, aka. And if our period is 2 pi over 3, we know that that equals 2 pi over b, and b is 3. Okay, so let's talk through that again. In order to find the horizontal distance of our frame, we took the end value, pi over 2, and subtracted the beginning value, -pi over 6. Okay, pi over 2 minus a -pi over 6 gave us 2 pi over 3. So we set that equal to 2 pi over b. Anything in particular you want me to revisit there? Okay, remember our starting point is where our frame starts. So if we look at this frame, our starting point is right here at -pi over 6, 0. So we know that D is 0, but we do have a C value. So let's keep in mind that C over B is how we get the X coordinate. And our X coordinate right now is -pi over 6. Do we know B? So I am going to erase B and put in 3. So now we can cross multiply. -3 times pi equals 6 times C. So C is -3 pi divided by 6, or -pi over 2. I would love to. So our starting point is -pi over 6. Okay. We find the starting point by taking C over B. So I took C over B and set it equal to -pi over 6. Well, B we know is 3. So I replaced B with 3, and then I cross multiplied. 3 times -pi equals 6 times C. So now we're going to divide the 6 over to get negative pi over 2. Okay, so we have y equals a cosine of bx minus c, and our c is negative, so this turns into a plus pi over 2. Since it's bx minus c and c is negative, we have a shift to the left, so we need to have addition inside. Okay, how about you do one without me? You and your pod, don't even draw this down. Just you and your pod work together on figuring out the equation of this curve. Okay, what x? Oh. Yeah, are you taking a math class today, or will you take the math class? Fair. Bishop, what does your pod think A should be? 2. A should be 2, and why is A 2? Okay, so we stretch from -1 to 1. So our total vertical height is 2. But our amplitude is only half of that. Thank you for reading my mind. Okay, so our amplitude is just 1. Okay, love it. Our B value. Eric, what do you have for your B value?
Is it 1/3?
Is it 1/3? He asks. I'm seeing some yeses. So let's talk about that. The period is 6 pi, and that needs to equal 2 pi divided by b. So when we cross multiply, b is 2 pi divided by 6 pi, which is yes, 1/3. So we have y equals 1 sine of 1/3 x. And your starting point was 0, 0. That's kind of an easy one, huh, to give you. Okay, so we have 7 minutes left in class. I'm going to give you this worksheet, and I bet that you can get the front half done before you leave. We're going to pretend that didn't happen.